Hi, I'm Kat,
And I'm Tom.
and this short video is just going to show you how to set up and use some of the online tools that we showed in our CPD session on the 30th of November. And we're also going to show you a little bit about how you can take the data and what your students do and incorporate more statistical conversations within your lessons. So if you head over to the RGS website and go to rgs.org/geomaths, you'll be able to find all of the links on this page. If you just go to resources, you'll see there are two Padlets. The first one is more focused about using Excel in geography. And in the second one is where we've collated online tools that you can use in your lessons or set your students as homework. Okay, you can see here that I've got quite a big collection of online tools that you can use with your geography students. These aren't things that we've created, but things that I have spotted in the wilds of Twitter often. In the first column, there are some videos here that you can use to, if you're not sure about how to use the Desmos activities with your classes, and also if you want to develop them and become, more confident with the computational layer and the fancy things that it can do. But there's some very straightforward ways of using it, and you can just use it today effectively. I'm going to focus on this one here, which is about rainfall and interpreting data. It's quite a short little activity, and it's just about gathering some information from your students. So if we click on this, this will take us to the Desmos page for this activity. Now you will need to register, which is free. You'll notice here that I'm signed in the top right hand side, but you might, just take you a couple of minutes to register if you haven't done so already. If you click on student preview, you'll get an idea of what your students are going to be doing in this activity. This one's all focusing about average rainfall in the UK, and we've looked at some data here about the average rainfall in the UK. And first of all, students are asked to order these from the least rainfall down to the most at the bottom. Tom, where do you think is the driest place?
I would say it's England, but I would also point out that myself and some teachers in the session I was in last night commented on how easy it is to assume that the top of the scale is going to be most rainfall. So
absolutely, yeah. And that is something that you can change in the activity. So if you'd rather have it the other way around, you can go in and edit it if you'd like to. I mean, growing up in Northern Ireland, I would say that it's very wet. So, I might put that one down the bottom there. So should we give this a go?
Yeah, that's.
Unfortunately, only one is in the right place. So because you see, you can submit it here. What's happening is it's recording our first guess, but you're then allowed to sort of rejig them and see what happens. So we've now got two countries in the right place. So let's go here. Yes, we've got them all in the right place. So you're able to find out the right answer, but as a teacher, it will record the student's first guess.
That surprises me that Wales is wetter than Northern Ireland, I have to say.
Yeah, it does. It just seemed to rain every single day of my whole childhood. And on slide 3, they then have to estimate, according to our data source that we're working with here, what would the annual rainfall in Scotland be? And I mean, I kind of feel like I'm cheating a little bit here because I already know the answer. So they just click on whichever one they think and then submit, and they're told that it's 1,520.
And I had no sense of that whatsoever when I went to answer it.
But we're not geography teachers, so they'll probably be a lot better than us.
Yeah.
And then on the next slide, what they have to do is, based on the fact that they know that Scotland is wetter than England, and they're going to estimate what they think it might be in England. So, Tom, do you want to give us a guess?
Yeah, I'd say around about half of that. So let's say 800.
800, okay. And then submit. So it plots your guess as a red dot. And then if you click on compare, what it does is it shows the other guesses in the class as well. So currently, because this is just a preview, we're looking at some data that we've stored in here. But when your class actually does this activity, all the other green dots will be all the other students that have guessed here as well.
What happens if
So,
you're the first student to have guessed, Kat?
so if you're the first student to guess, you get the data that's stored in here. And then as some more people do it, then you get the real data. So I would suggest if you did this with your class, you might want to just spend a few minutes getting your department to have a go so that you could use that data with them. So it all feels real.
So how many people need to have entered data before it goes to the live data rather than the stored data? Do you know?
Just more than one.
Oh, okay.
Yeah. So it would be nice if a few people, you had a few teachers perhaps having a go first of all, because it's quite difficult to compare with just 2 points.
Yeah.
Not as interesting. So, and I think it's a nice thing to share with teachers as well, because, then they get to see the tool and it only takes a few minutes to do. So it's quite an interesting thing to do as well.
And I think what comes next in the activity, it's really useful to have a reasonable amount of data in there already, isn't it?
Absolutely, yeah. So what students are doing now is hopefully having a look at what other people guessed and thinking, oh, they're a bit different to mine, or they're the same as mine. Because on the next slide, they're going to be asked to revise their guess based on what they've seen before. So would you like to change your guess, or are you going to stick with it?
Can you go back so I can see the distribution again?
Yeah, of course.
Thank you. Well, it looks like I'm under the average guess, but I'm bearing in mind these are all guesses anyway. Mm-hmm. So, there is an expression, isn't there? The wisdom of the crowd, but I don't know how wise this crowd is. But I think I probably will hedge my bets, and I might shift my guess up a little bit. So I'm going to go to 900 millimeters.
Okay, so we'll do that. So let's go 900 and submit that and compare. Interesting.
So those are now the second guesses, are they?
These are the second guesses. So it's quite nice because on the next page, you get to see both of them side by side, which is a bit more useful.
That's really interesting to me, because what I've noticed there is that in the second guesses, you've got a much narrower distribution than in the first guesses. And so, that's a really nice way of illustrating what happens to the spread of data when you have a crowd involved.
Yeah.
And it's a wonderful way of introducing ideas like standard deviation or interquartile range or something like that to a class.
Yeah, I think it's lovely because it's asking a question which is really non-threatening. So it's just, what do you notice? So it's not saying, calculate this or calculate that. And, everyone can sort of comment on it. And it's starting with the informal conversation before you get to the maths. So what would you like to do, as a teacher, where would you like to take it next?
I'll tell you what I'd be really interested in is if lots of different classes in my department were to use this, was this happening all the way across all those different classes?
Yeah.
Is this a common, or is this just a one-off for this particular class? Because I would suspect that it's tends to happen.
Yeah.
That would be my conjecture. So I maybe would collect information from all the classes, maybe the summary statistics for those particular distributions, and get each class to submit them into maybe a Google form or a Desmos activity, perhaps, and then have a look and see what's happening across the board. And also, if I was working at level 3, then perhaps I would use this as an opportunity to introduce the idea of standard deviation and see whether I can use this data as a springboard to introducing that idea and that method.
Okay, so on the last slide, this is really just an illustration of how a box plot can be used to sort of summarize a data set. And I mean, this is a fairly small set of data here, but they can be really, really powerful when you've got a really big data set to see what's going on. So go on, Tom.
Well, I just think that box plots are fantastic ways of comparing different data sets. So if you had a box plot for the first guess and another box plot for the second guess, then you can draw out the key features of those two distributions through the box plot, can't you?
Brilliant. Yeah, and there are other Desmos activities within the Padlet as well, that they will just take a student's answer, whatever the question happens to be, and it will immediately draw a box plot for you. So
I think it's worth emphasizing to students, because they don't always realize this, that each part of a box plot is 25% of the data.
Mm-hmm.
That's a really nice way of thinking about it. But the reason why the box is kind of more pronounced than the whiskers is because it's much more reliable data. The middle 50% of the data is much more reliable, whereas the outer 25% in either end of the box plot, that's where you could have outliers getting in the way, and it can draw out the whiskers. So the whiskers are kind of being reduced in their prominence within the plot because actually it's not so reliable. I just noticed actually, Kat, that the end of the whiskers here, which are your maximum and minimum values, aren't exactly in line with the dots, it seems. It seems like
So yeah, these dots have been rounded when they've been plotted. So you can see here that the range of the graph, the minimum value is actually 22.7.
Oh, okay. And
so
it's actually plotted the dot at 2020, has it?
Yeah, the dot was just positioned there, so it was rounded to
I think that's fine, but I think it's useful to know that, because a student might ask you that.
Yeah, and then I think it's interesting because you can have the median there, the middle value there, and then we can also put the mean on. And I think that is a really interesting point, because I think the word average is just used so often, and it's not clear which average someone's talking about. Why is the mean higher than the median in this case?
That's a good question. I presume it's because of those two larger guesses.
Yeah, these 2 points here are kind of dragging it up, whereas this median wouldn't be affected if these 2 points were moved down.
No, that's right. Yeah.
So
that's always a nice question, isn't it? Is what's causing the difference between mean and median?
Yeah. And then questioning, if someone's given you one of those values, why have they chosen that particular one? For what reason? And if you knew the other one, would it be a different story? Okay.
So can you just show me what happens when you click on standard deviation?
Here we go.
Oh, okay. So those are outside of the box. They are further along. Why is that?
So this is just calculating the standard deviation and then doing it one standard deviation away from the mean.
And so standard deviation contains more data, doesn't it, than the center 50%?
Yeah. Yeah. Well, in
2/3, isn't it, generally?
Yeah.
Which is why they extend a bit further.
Yeah.
That's fantastic. I love that.
Okay, so I'm just going to show you how to set this for your class. So if you click on the assign button here, you can either generate a single session code, or you can assign it to one of your classes. If you haven't set up a class yet, if you go to the left-hand side where it says manage classes, you just need to send a link out to your class, and then that will form the class, and then you can just assign it to them. I just did a single session code here. And then once you've done that and provided that code to your class, then as they're doing the task, you will get to see the results coming in here. So this is what it looks like as a teacher. And you can see in the top left-hand side here, I've anonymized all these answers, all these people who've done the task. So when students are doing it and they're seeing other people's answers, they don't need to feel worried about what they're saying.
So the various teachers will know who they are in terms of the famous mathematician's name.
They will, yeah.
Nobody else will know who they are unless they tell them.
Exactly, unless you choose to take the anonymize off. And you can pace it as well. So if you're doing this in a live lesson, you can say, oh, well, I actually only want students to be able to look at these first two screens first of all, and then as time goes on, I'm just going to show them bit by bit.
It's great, isn't it? And you can pause the activity as well. So if they're all working and you want their attention, that's probably more effective than going, class, stop working.
Absolutely. So it's brilliant. And there's, like I said, there's so many here that you can play around with and have a go and copy different slides and make your own one from scratch. There's just endless places you can take this.